Hi and welcome to DCO. My name is David Copete. If you're new here, what I do is I create parametric design scripts using Grasshopper. And in today's video, I'll be going over an entire tutorial sharing with you how to do this, which is going to be creating a base form for a building, starting with the walls, getting into the roof, the parapet, then doing the foundation. But the critical thing about this is being able to take a different input, a different line segment. It could be as complex as you want. Let's create this input. And now we can override that input and be able to do that exact same thing for any line segment. This is a polyline, but we can also do that with a curved segment. So I'm excited to share with you those steps. Hopefully you're excited to learn a few more tips and tricks on how this can be used for your benefit. It can be used to program your design so you can use different inputs for it and use them over and over again. So thank you for being here and let's jump into it. All right, so to start this tutorial, the first thing we're going to need is a new Rhino file. And now the units are not going to matter. The only thing is, depending on what units you have, you're going to have a different slider. So the first component we'll bring in is going to be construct point. This is going to give us a parametric point that we can use right away. Then I'll use an empty point component. Now, if you're seeing things a bit different in my Grasshopper file, it's going to be because I have my display, draw icons, draw fancy wires, and draw full names. And this way you can see the input names, you can see the icons, and you can follow along. All right, the next component is going to be a rectangle. So we'll bring in this rectangle component, which lets us plug in this point into the plane input, giving us and allowing us to put that rectangle at this point. Now let's change the X and Y size. So this is what I was talking about when, depending on what units you have, this is going to be a different slider number. I'm using 240 and 240, so I'm keeping this a rectangle. But the cool thing is that you'll be able to use any polyline for this exercise. We'll just be using a simplified version of it at the beginning, and then I'll show you later on how you can change it. So here with this rectangle, we'll bring in a curve component. This is to be able to create the whole script off of this, and then later on, we'll be able to plug in a different curve like I said. Okay, so now with this, first thing we're going to do is offset it to the inside. So we'll go here to offset curve. Since it's offsetting to the outside and I want to keep the outside polyline as my actual size, I'll bring in a negative component and then use a slider to change the size of the offset. All right, so now with this offset, we can always change that input. We'll keep it here at 6. Now what I want to do is create a surface between the two. In this way, I can extrude it up as a solid. So I'll move this down, bring in a boundary surface. But here's the issue is that when we plug this one in and we plug this one in, you'll see that we have an overlap of surfaces. And we can tell that because we have that distortion going on here. And the reason for this is it's looking at them as separate line segments. So we can do it this way. We can bring in a graphed tree, then use this as the input, and then we could use the offset. The other way is we can flatten the input. So there's two different ways of doing it, and that has to do with the way that things are organized. This makes sure that they're looked at as one, and then it creates that surface. So now let's move into extruding this. So we'll use an extrude component. The direction is going to be up in the Z direction, and the input is going to be the height. So now that we have this, we can hide the initial surface that we created for the wall. And now we're going to be taking the outside line segment, which is the original one, and we'll be moving it up to that same location as the extrusion. So we'll go to move, and then we could tie it to the height of the wall. So we'll go plug in the Z vector into the motion, and then move that original line up. So what this does is ties it to the wall height, and whenever we change the wall height, we're going to change the location of that line segment. Now we're going to be turning that into a surface. So let's go here to boundary surfaces. And now we're going to be creating the roof portion. So now I'll just copy this over. Tap Alt. Why? Because we already have this extrusion with the Z vector here. All we need to do is change maybe the slider, and we can plug this in. We'll bring in a slider. We can create a custom slider as well between 0, less than 6, less than 24.00. This will give us a slider from 0 to 24, put 2 decimal points, and set it at 6. Now that we have the roof portion, the other thing we want to add is this would be the roof rafters. Then you're going to have the roof sheathing right on top. So we don't necessarily have to do that. We could just keep it as a solid and then account for that within the massing here. But I think it's a good idea to show that if we move this surface up by the same amount as the extrusion we just did, we can also tie that movement to the height of the roof. And then we can extrude this by whatever roof sheathing material number you're going to have. So I'll take this, slide it over, tap Alt, and then I'll use this as the input and change this. So if we want, we could use the same slider, or we can create a new one. For the roofing material, sometimes you'd want to have a few more decimal points, because sometimes the material, when you buy it, it's going to be varying in that sense, and you can have a little bit more control. So with this, now we know that from here to here, it's going to be these two vectors added together. So what we need to do now is take that line segment and move it up to that location. So we're going to bring in another move component, which I'll copy this one. Then use that line segment to move up. And the way that we can tie these two vectors to that movement is by adding those two vectors. So we'll add the 12 and the 1.5. And this we can use straight as the motion, and it will move it up to that location. So the reason we're doing this is we're creating the parapets here at the top, and we want to be able to change any material size or any roof depth to move that line segment to that same location. So now what we'll do here is take that line segment. We're going to offset it. And we can offset it the same way that we did for the wall. So I'll take this. I'll take the graph tree. And what I'll do is I'll double click here, because that curve component had two different outputs. And when you create a relay, it creates just one. And we can copy all of this, slide it over. When you tap Alt, it creates the copy. You can also do Control C, Control V, and we'll plug this into it. So what we have here is that we have the parapet size here at 6, and now we've created that surface in the same way that we created it down here, but now we can use this and extrude it up by copying those components, because we already have that step made, so we can save a little bit and be more efficient this way. So now let's increase this, and we can even have the parapets be even higher. So with this, you're starting to see how we can use parametric designs to create the entire script off of this curve. And so let's continue on. I want to show you the other critical part, which is going to be the foundation. So of course, out here with this form, out here we would have the material. Inside we would also have some material. The roof would also have some slopes. So those things I'm not going to cover, but I definitely want to show you how to create a slab on grade foundation for this script. So a slab on grade foundation is a footing that is made out of concrete. It has the footings on the outside and it has a floor slab, and that's set right on the ground. So what we'll do is, using similar steps, we're going to be developing that here. So we'll take the outside line segment, and some of these are going to vary depending on the soils or depending on your engineer, but this is going to help us create the overall shape and form of what a typical foundation would be. So we'll go to a move component. We'll take this line segment. We're going to move it down. So I'll bring in a vector, a unit Z, and a negative component. Then this is going to determine the depth of your foundation. So we'll go here to 24. The next thing we're going to do is create the depth of the footing. So we're going to offset this in the negative direction. So we can just copy this one over. And we'll use, again, this slider, or a slider with the larger number. So this is going to determine the width of your foundation. So we'll go here to 24. Now the next part is going to be taking this, we're going to move it. So we can copy a move component or just bring this one in. And then we'll be moving that up by the depth of it minus the floor slab. So we'll take 24, we'll subtract the floor slab. So we'll say 6. And then we're going to be moving this up in the Z direction. Now there's a detail here when you look at a slab on grade, that there's a chamfer between this and where the floor slab is. So we can just create it like this, create it as an extrusion, or we can also include that here in the script. And I'll be definitely doing that. So let's go here to offset. Once again, to the inside. But this time, this detail is going to be by around 4. And that's due to when they excavate the ground to create the footing, you never really have a perfect extrusion up to the floor slab. There's usually a bit of a cutoff here in the corners. In that same amount that we offset, we're going to take this and move down. So we'll copy this move, or we'll move with the different component. Either way works. And move this down in the Z direction. So -4. We'll move this down -4. So what this does is it makes this the old one. And now what we're going to do is bring all of these together into surfaces. So what we can do is now go to our wall, hide it, and now we can start seeing what we need to create the foundation. So this offset is not critical in this portion. So now let's go to our line segments. So the original and this one need to be connected, so we can use a loft component between those two. Next is going to be this one, that one that we moved down, the depth one, with the offset for how wide the footing is. So I'll make a copy of that loft, use that line segment to override both inputs, and holding down Shift, we can add more than one. Now, you're seeing that it doesn't create the surface, so we can either use graph tree or flatten input. Now the other way is we can use a boundary surface because they're on the same plane. Next, we need to create the loft between these two. So using that loft component, use this and this one. Then these two. I'll use a graph component. And lastly, this one that we offset to the inside, we need a boundary surface. In the original top one, we also need a boundary surface for that one. So I'll copy this one and override it with this one. Now also notice that everything is off of this line segment. So what we need to do at this moment is take all of that new information and all of the new surfaces. Now we're going to join them together using brep join. Holding down Shift, we can add more than one input. And so once we flatten that input, we should have a closed brep. So I'm going to hide all of the inputs from this because what we want to see at the end is going to be that solid foundation, and it's based off of this 24-inch depth. Then the slab height, which is determined by this slider. So it's a 6-inch slab. Then the chamfer portion, which is an offset and a movement down, that can be increased, but typically you'll see it at like 4 inches. And then the width of the footing, which for one floor would be, let's say, around 12 inches. Then for 2 floors, sometimes you see 15, but we'll keep it here at something like 20. And now let's bring back that wall. Here. So what I like to do here to keep things organized is I like to place these extrusions and the solids that I'm going to be using or that I want to bake here into a geometry component, which is empty, and do the same thing for this one, do the same thing for all of the materials here. And sometimes even group it with a specific color, which you could change. This way I can hide everything else and know that those are the objects that I need to keep in mind. So here we have these. And at the end, we'll have this one. Some of these wires are a bit crazy when you have them all overlapping. So for some of these that go over from the beginning to the end, I do like to go to wire display hidden. So right click and then change that. And this will help you keep your script a little bit more organized. And you can always select the component and see where things are plugged in from. All right, so now here, the next part is going to be to hide everything else except for those components with the resulting geometry. This way we don't have things that are overlapping or we're previewing things that we don't need to. And the cool thing is that we can always go back and see how things are made, and we can use portions of the script, let's say here, to pick a point in the middle and create a subtraction for a door or for a window. So those are the things that we can always go back to. And being able to see the entire script of all the steps that you would take is going to be really useful because it'll also help you understand how to do this without a script. These are the exact same steps that I would take for creating a mass form without Grasshopper. But when we do it here within a script, what it'll help us do is this. So now that we have this, let's save the file. So that way we can play with it a little bit. So once you have your thing saved, now we can bring in a custom preview. Bring in a color swatch. And for custom previews, I do definitely like to hide my wire display input. This way it doesn't tie it to that one, but we do know that it colors it. Then change the color here. Sometimes I use grayscale just to keep it simple. So let's go here to, let's say 80. And then I like to copy those over once I have that set up to the other portions. Now we can keep them the same. So holding down Shift, add more than one input. And then we could hide and then I'll copy this for the foundation, which I will make a little bit darker. I'll make the gray value to like 50. And maybe the depth doesn't have to be that much. Okay, so now that we have the entire design here. Let's now plug in a different input. So I'm going to first start by creating a polyline. Now, obviously, it can't be any smaller than like how thick the wall is or how big the foundation is. It has to be, there's some limitations to it in the sense that you can't make it too small, but we can create any shape building. And I'll use my smart track and then C to close it. I'll bring it over here and use this as the input. So I'll set one curve and use that to override the design. Now let's see why the foundation's not working here. And that's because I did the override to the wrong one. It has to be override to this one, right? Because that one is where all the other portion of the script, and this makes sure that it also goes to the foundation. Okay, so notice here how by creating a simple script here at the beginning, then we can take that concept, and as long as we did things correct here, this is not even that large of a script, we can now take the end result. So I'll hold down Shift to add all of those inputs, middle click, bake, and then I'll hide the script here by going to this icon. Now I'll go to layer 1 and create a clipping plane. So this is going to be more within Rhino. And then go to a vertical section and see that it creates that entire portion of the design, which is a simplified version of the overall building form. And it creates it very clean, very accurate with all the inputs that we can change. Now the inputs that I used were going to be for like a wood framed wall and a typical slab on grade foundation. But that doesn't mean that you can't take similar steps and create a different foundation type, or that you can't use the slider to increase this to be a concrete wall. Now, obviously, there's going to be supports here for the roof. There's also going to be other things like the roofing material, like the flashing, but I'm going to show you some scripts here that I've made showing you how much further you can take this, and you can even go further than that. So let's now delete this because let's go back to the script. Let's plug in that rectangle again. And now let's use a interpolated curve. So right now I have my snaps on, where I have my ortho on. I'm going to take ortho off. I'm going to use an interpolated curve. C to close. And then use this as my curve. So set one curve. And not only can it create a rectangle like what we had originally, but it can create any form, because the steps that we took could be created for any shape. And similarly to what we did before, is now we can go here to clipping plane. So let's do the clipping plane here within Grasshopper. All of the details will be working here. That's why I like to bake it, is because when you use the clipping plane within Grasshopper, it just won't be as clean. But here, now when we have the objects baked, you'll see that everything is a solid. You have the roofing, you have the roofing material, Obviously, the rafters are going to be arrayed here, but this is going to show the massing of where they're located. Same with the walls. You wouldn't have a solid wall like this. You would have wood members that are repeating to create the wall. But the interesting thing about parametric tools like this is that we can create an entire building form with just one polyline. So now, with this being the conclusion of the tutorial, let me show you some of the scripts that I made that are a little bit more detailed to show you how far you can take some of these scripts. All right, so check this out. This is going to be very similar to what I showed you here in the tutorial. The difference is that here I've organized it within a cluster, which is taking that whole script and organizing the inputs, organizing the outputs, and creating some custom previews for them. But now let me show you here, similar to what we did before. I'm going to just create a polyline for the building form. I'll set one curve, override the curve input, and I'll create a new layer for this one, call this building form, make that my current layer, and then I'll go here to the outputs and bake them. And when I bake them, they'll bake into this building form. Now there's other ways that we can bake it into a layer, but this is the way that I like to do it. This way I can organize the information that comes out of Grasshopper. So I'll go here to middle click, bake, and it will actually bake the materials into it as well. But with that being said, now I can go to building form, select objects, and move it over to the side. So let me show you the difference between this script and the one that we just went over. Is this one has the details that will ensure that it can be built and that it's safe, or not necessarily safe, but it has the measures taken in for things like the flashing. So let's create a clipping plane. We'll go here to vertical. And so this is going to have the slab on grade foundation. It has the wall. It has the roof material. Then it has the parapet. Then it has the exterior material, which is overlapped for the exterior. Then we have here a wood nailer. This is going to be at the top, so it's sloped and it slopes to the inside. Obviously, we don't necessarily have a roof slope here, but this is going to show you part of the waterproofing that you would need for a form like this, which is when you have an interior and exterior material, you need to have a bit of a slope here and create some flashing. Now this flashing is created so it overlaps the nailer and the exterior material. And all of those details kind of help add a bit more to the script, but also help you save a little bit of time in terms of being able to program your designs and just be able to change that input. So I'm showing you here this one that's a little bit more detailed. And the way that I made this one was by going back to the original and organizing each of the portions separately. So this is going to be the interior portion. Then I have here a slab on grade foundation portion. So I've separated these because sometimes if you just want to create a slab on grade with the script, I can have those as a separate portion of the script. This is going to be the exterior material. This one's going to be for the flashing. So I've organized the entire large script into smaller ones, and then later on into a master one that has all of them included. So hopefully you're seeing how far you can take a design, but the idea here is that you can learn a few more tips and tricks that can show you how you can take your designs, create a script or program your design, and then be able to change it for future use. So thank you very much for being here. Hopefully you learned a few more tips and tricks. If you liked the video, make sure to give it a like, and I hope to see you in the next video.